All right, last example here. A light bulb manufacturing company makes a claim in an advertisement that their light bulbs last 500 hours on average. So, because we have average, that means we're talking about mu, so they're making a claim about a population mean. We would like to test their claim, so you collect a random sample of 35, so n equals 35 light bulbs. You find a sample mean of 496 and a standard deviation of 10. So this is a sample statistics. So sample mean X bar is 496, S is 10. So for this one, we have what type of test? It's either got to be Z or T. So it all comes down to your standard deviation. Because we only know the sample standard deviation, that is our indication that this is going to be a T test. Null and alternative, H sub O, is what are they claiming? They are claiming that mu is equal to 500. What do we think? Our alternative, there is no language in there that suggests less or more, so we simply use not equal to 500. And our alpha value is going to be 0.05 because we were not told otherwise. So going on to our critical value and test statistics. So I've got my t-test side of the formula sheet. So my critical value being a two-tail test, and I know it's two-tail because we used not equal. So being a two-tail test, we're using inverse t. So we find that under second vars. I have to do alpha divided by 2 and my degrees of freedom. And remember, degrees of freedom is your sample size minus 1. So I have degrees of freedom of 34. So I have a T critical of 2.03, and because it is a two-tail test, we have negative 2.03 and positive 2.03. So two separate regions on our normal curve that are considered our reject regions. Okay, so the next thing that we have to do is find our test statistic, and here's our formula. So we're going to use X bar, which was 496, minus mu, which was 500, divided by S over square root of n. Okay, so I get a test statistic of negative 2.37. And it's negative, which should make sense because we're less than the population mean, so we're below average. So negative 2.37 is pretty close, but it falls out here to the left of our critical value. It falls in our reject region. So the first part of this, the first of three things that should all support the same decision, my test statistic and critical value are telling me that I'm going to be able to reject the null. So the next thing that we want to find is our p-value. So we're doing a two-tail test. So I'm looking right here. I need to find TCDF, and I'm going to use the absolute value of t. So positive 2.37 to infinity, and my degrees of freedom was 34. Because it's a two-tail test, we have to multiply this value by 2. So we get a p-value of 0.023. Now remember, the whole idea with a p-value is we're trying to compare it to alpha. So when we look at our alpha value, we want to make this comparison. And again, if it helps, think of it as percentages rather than these decimals. So moving your decimal 2 places over, this is 2.3%, this is 5%. So in our case, our p-value is less than alpha. So this also supports the decision that we get to reject the null. So far we have two things that tell us we get to reject our null hypothesis. So the last thing is, calculating our confidence interval. Since we ran a t-test, we need to run a t-interval to match. So stat test t-interval. Our sample mean was 496, standard deviation 10, sample size 35, confidence level 95. Okay, so now we want to, again, point out the fact that all three of these things should support the same decision. So we decided to reject it. And the last thing is making sure your confidence interval also supports that. So this one could be a little bit tricky. And maybe some people could argue because they made the claim that the average was 500. The high end of our confidence interval was 499.4. So it's pretty close that some people could make the argument of sure it could be 400. But our interpretation is we are 95% confident that the true, we'll say the true mean bulb life is between 492.5 and 499.5 hours. So does this support the decision to reject? Yes, because 500 is not in that interval. So we're 95% sure that the true mean is somewhere in that interval. And since 500 is not in that interval, we can be pretty confident that it's not 500.